Or is that
All right, shut up! Love that. All right, so first of all, if you didn't notice, all the hackathon teams are up. Hopefully you did notice. You should be checking Slack often. So it's in general. So all the hackathon teams are up here. Here's the teams. Anybody in orange is a team lead. Team leads should be reaching out to all of their individual teams. Team members should try to reach out to their team leads. Hopefully getting everybody in communication with each other as soon as possible so you can start brainstorming ideas and things like that. There are something like 50 people signed up, which is good. Then after this, I have the guidelines for the project. So depending on whether you're on a mobile application team or a virtual reality team, projects for mobile projects must be written native iOS or Android. So most of you have not had experience with either of those. So you'll be learning from your team leads or other people on the project. So from your perspective, it maybe doesn't matter. Whatever kind of computers you're sitting in front of. Project must support Google Firebase's database. Also, most of you are not going to have experience with this, but that's something that a lot of the upperclassmen have worked with. Don't put authentication in the project. That just takes extra time. You know, people logging in with usernames and passwords, it's all cool. Most applications have that in there. You'll spend 60% of your time at the hackathon writing the stupid username and password login stuff. It's not hard. It's just tedious. Fake it in your projects. Your team leads will know what that means, but just don't put that in there. Project must capture some data to store in the database. So, you know, somewhere in there, maybe you're writing an app that's cataloging your video game collection or something like that. You should have a screen that takes in the name of the game, maybe the year you got it, and maybe a summary of, what the game's about or something like that. Just as an example, there's got to be some screen in the app that captures some information about whatever your app is doing, and then it has to store it up in Firebase. It should also be able to pull stuff from Firebase, and every single team is going to get, if you're an Android or an iOS team or a VR team, you'll get a starter project that I'm putting together that will already be configured for Firebase, that will already have examples of writing to and reading from. So you won't have to spend a whole bunch of time learning those things, although I think all the team leads have had experience working with it. Must solve a real world problem. Let's call that an ish type thing. Just want you to try to think about something real, like I mentioned, cataloging your video game collection or, writing a Dungeons and Dragons dice roller, that kind of stuff. These are the kinds of scope of projects that you would have at a hackathon for a 12-hour project. All right, so, when you're working with your teams, hopefully you guys are communicating this week, whether it's on Slack or via email. You're kicking back and forth ideas that you might want to implement. You want to think about, what is reasonable to get done in about 12 hours, and your team leads will be able to best direct you for that because they'll have an idea on how hard some of these things are to do, but solve small problems so that you feel like you have a little victory at the hackathon, that type of thing. So that's mobile. VR, if you're on one of the VR teams, project must be written in Unity using SteamVR as the native VR library. And I'm providing you with a Unity project that already has SteamVR in it, already has a little scene that you can teleport around in there, already has a little spot teleport thing where you teleport right up to this little table, and it has some items on the table. You can pick them up and throw them and drop them on the ground and that kind of stuff. I used the stuff that you put in there. You have some platforms that So there's some other platforms in there where you could teleport up on some bricks, and you have to kind of teleport from 2 or 3 different platforms to get up on a higher platform. So you kind of have a starter project that allows you to, have some mobility and interact with stuff with the hand controls. And that project will work on any of the headsets in this room. So any of the mixed reality headsets, HTC Vive, or Oculus Rifts. So whichever computer your VR team gets assigned to, it'll work on that machine. That's why we're using SteamVR. It supports all of them. So a project must support locomotion of some type. Like I said, I'm giving you teleportation. So if that's good for you, where you just kind of point where you want to go and the thing has a little arc that says, put me there. It already has that. So now you just need to put it into some real world use. Must take advantage of tracked hands. So already have the ability for you to like pick up crap and toss it in the air and grab it with the other hand and stuff like that. So put that to some real world use. Yeah, so in any case, those are the VR guidelines. So, projects might be like a walkthrough of the computer science department where maybe in each classroom you can interact with some stuff. It might be I don't know, let's see, last year we had one team, and it was maybe a more advanced team, so this would be a pretty, I don't know, that complex. How many of you remember the game for Windows called Minesweeper? Mm-hmm. They wrote Minesweeper in VR. So where you were the, like, in Minesweeper you click on the spot and then you either have bombs around you or whatever. So you would teleport to a spot and then things would pop up around you in terms of how dangerous, and then you would have to teleport to other spots and things like that. So that was kind of a cool project. Another team last year did like a parachuting simulator thing where you would jump out of a plane, and so your VR guy, you're controlling, you're falling to earth, and there's like a target that you're trying to hit. And you have some, with the hand controls, you can kind of adjust, like your wind, how you're catching the wind to kind of move towards that target, that kind of stuff. And so things like that are kind of the VR experiences type things. All right, questions about any of those things? All right, then for the unfortunate people who are not doing the hackathon, you can read my little manifesto here from this morning as well as the assignment. It'll be a fun one, as I promised. So that's the deal with that. Go ahead.
Yeah, so for the hackathon, will there be like any prizes that do not include grades?
Any prizes that don't include grades? What do you mean?
Like,
can you win things?
Yeah, exactly.
Oh, yeah. I think usually we hand out like iTunes gift cards or something like that. That would be more of Dr. Locklear's department on what we're handing out. But there's stuff, yeah. Not as good as the CS get-together stuff. The CS get-together where we have, like the PlayStation VR thing, expensive things. Historically, I think maybe the winning team has gotten maybe like $20 or $25 iTunes gift cards. And then they get a little stupid plastic trophy. I think we're handing out sunglasses, CUWCS sunglasses, crappy sunglasses.
We have sunglasses.
So, yeah. So, I don't know, something like that kind of stuff. Yeah, but you get free food, breakfast, lunch, and dinner, and there'll be snacks and soda and all that, and coffee, all that stuff.
Okay.
Does that answer any other questions about the hackathon? Or the people who are not going to hackathon still reading the penalty assignment and deciding how much they're going to bribe me after class. Now, another opportunity. I want to make this available to everybody in here, but I also want to say it is a time commitment. A couple people in class have already committed to doing this. I had some students come in this weekend. We did some, I was getting the base project set up for the virtual reality for the hackathon. So figured if I'm going to be doing it anyways, if some people wanted to come and watch, and I posted that on Slack if you were interested. And we got to talking about creating a game in virtual reality. And so historically, I was part of a research project. Well, I ran a research project called Bible VR, where we were turning various Bible stories into virtual reality. So, for instance, the very first experience we wrote was the Moses talking to the burning bush. So you play as Moses and you hear the voice of God. And you kind of have to teleport up to the mountain, and then this bush catches fire, and you have this whole dialogue back and forth with God, and then you go into the plagues and that kind of stuff. And we got maybe a third of the way kind of through that. And then the students that were working on it kind of fizzled out, and then the summer happened and that kind of stuff. But we were talking about it, and there's a game I've been. Reality is starting to hit with VR now. Some of you have seen the Ready Player One movie. If you haven't, remember Grace is going tomorrow night. It's I think the movie's at 7:15. I'm pretty sure they already bought tickets, but if you really, really, really want to go, reach out to Alexis Rollins, and then we could probably figure something out for getting you over there. But we're meeting over there at probably 7 o'clock for the 7:15 show tomorrow night, and tickets are only $5. And you can buy them at the theater as well. But I really recommend that movie. It's about VR and kind of pointing towards the future of where we're going with virtual reality. In this movie and also in the book, effectively, a majority of people's lives are spent in VR. Kids go to school in virtual reality. Those are the best schools. If you're going to school in the real world, that's like the poverty people. Okay, if everybody else is going in VR because those are where the good schools are. Everybody's playing various games, all their athletics and stuff is all in virtual reality. Now, this is kind of sci-fi-y, but what's very interesting about this is pretty much everything that's in that movie exists today in some form. What we don't have yet is the full integration of all those pieces. There exists vests that will work in VR that when somebody punches you, you'll feel it. Those exist. Haptic gloves where when you reach down and you grab something in VR, there's a virtual apple. You reach down and you grab that apple, you feel it. Those exist. They're either in development or very, very, very costly and not integrated into every experience. So we fast forward, let's say 3 years, those things are going to be reality. We rewind 3 years, they were just announcing VR headsets. They weren't even talking about the hand controls. Now we have cheap VR headsets with cheap hand controls. You could have a whole setup for $225. So in any case, this is really the direction things are going. And, the students and I got to talking, and this game I've been playing is called Orbis VR. And if you've ever played a game like an MMO, massively multiplayer online kind of game where you're in this world with a bunch of other real people and performing some tasks, so typically MMOs, it's kind of a medieval themed or something like that, and you're performing quests or you're grouping up with other real people to kill off monsters and this kind of stuff. So the core gameplay is pretty much the same across the board for any MMO. The storyline is what changes. And what we got to talking is, I was telling about the Bible VR projects we worked on in the past, which were kind of more of an educational thing, and we thought, what would be cool is if we made an MMO in VR based on the Bible. So we're kind of thinking, you probably wouldn't want to have like a boss fight like against Jesus. If we're keeping that along like the Christian storyline, that fight probably would not go well. So we're kind of thinking that the players in the game are all angels, and there's like different choirs of angels. So what do we have? We had Seraphim. So if you're a Seraphim, you could either be a Seraphim Demon Hunter, which you're kind of like, that's your wizard class where you cast spells, or you can be a Seraphim. Was the other one Acolyte? No.
It was,
Summoner. Seraphim Summoner. Yeah. You like summon minions to fight for you. Then we had Cherubim. So you could be a Cherubim Priest, which is like your healer type. Or a Cherubim Acolyte, which is like we're not set on that name yet, but that would be like crowd control, like keeping people busy instead of them joining the fight. And then we have the choir angel called Throne. So we have a Throne Defender, which is like your tank, and then a Throne Destroyer, which would be like your melee damage person, swords and that kind of stuff. You're fighting evil, and the idea is that you're in heaven, and time doesn't really exist in heaven, so. All the quest givers and stories you're playing through are all Bible stories. So you can go and play through the 10 plagues. So you kind of teleport from heaven down into Egypt during that time period. Yet you could also visit that time period in a different story during a different time period, or the same place during a different time period. So this is kind of the broad idea. So we started thinking, why don't we write this? This is a big project, and you'll learn a lot doing it, but it is going to be a major time commitment. So for the rest of the semester, this is when we're meeting, and you would have to be able to show up to pretty much every meeting if you are interested in doing this. Because what we're going to do is for the rest of the semester, we're going to be working through a Udemy course on 3D game design. We're going to build 3 different games to kind of get everybody up to speed on writing video games in Unity 3D stuff. And then we'll apply that to VR things, because you'll see that going from a normal 3D video game to that same game in VR, it's not a big deal. All you're doing is swapping out the camera, the normal camera for the game, and putting in the VR camera rig. And then you have to reimagine the controls because you no longer are using mouse and keyboard or a hand control. Now you got these things in your hands, and like, how do I do what I used to do with my Xbox controller now with this? Because that's the real difficulty. But in any case, I want to make sure this opportunity is available to everybody. So first meeting is tonight at 4:30 till 7. We'll meet right next door here. So if you are interested in this, go ahead and private message me today. But like I said, you'd want to show up. If you missed a meeting every now and then, wouldn't be the end of the world, but we're talking 95% attendance if you want to take advantage of this. There will be other smaller opportunities, but this is something we'll probably also continue through the summer to some extent. A couple of the students are going to be here. Some of them are going to be remote, so we'll have to figure out how to work together. But between now and the end of the semester, we're trying to get everybody's competence up to a point so that we can work on the project on a regular basis during the summer. So in any case, I wanted to make that available to everyone so nobody felt like they were left out. Questions about that? Good? All right. I think there's currently 4 people that are doing this. I just wanted to make sure everybody else knew about it. Okay, so let's look at our homework, right? Homework was Insertion Sort. Mm-hmm. Okay, so we're writing Insertion Sort in Python, and we went through and looked at the algorithm for doing this guy last time. Where did we write that last time? Oh, here it is. Yeah, so the algorithm for Insertion Sort last time, where we start everything off, if we go ahead and kind of, let me just mix these up again so we can review it. So that's a 3, that's a 1, that's a 2, that's a 7, that's a 5. All right, so we're gonna do this as if we're doing it originally. So we're gonna have a variable called current start that's gonna start off at bucket 1 of our list. Similarly, we're gonna have a variable called follower that will start off at cur start. And we want cur start to go on a voyage from the beginning of the list all the way to the end of the list. All right, so that's our stock for loop. So let's go in and start with that. So we'll get rid of this. So we're going to say for cur start in range 1 to length of, in this case, I named my list elephant. Okay, not a great variable name for our list, but this will at least really drive that point home that what you name your variable here, while it should be descriptive about what you're expecting, it does not have to resemble the word list. All right, so this is as far from list as we can get without using profanity, probably. Okay, so cur start, we'll start off at 1, go all the way up to the last legal bucket in our list. That is the length of the list minus 1. All right, so this will take, that loop right there will take cur start on that voyage from here to here to here to here, and then finally be done. All right, each time through, we want to have a variable called follower that starts off being equal to the same thing that cur start is equal to. So we'll say follower is equal to whatever cur start is right now. Okay? Then we ask the question, are we at the beginning of the list? Is follower at bucket 0? It's not. Therefore, we definitely have somebody behind us, somebody before us, right? All right. So we want to ask the question, if we are at bucket 0, or if we're at something greater than bucket 0, then I need to check the guy before me. So let's start off by asking this. So we're going to say, while, because we want to do this potentially multiple times, right? Let's start off with, we're going to write an if statement first, and then we're going to see why the if statement isn't good enough. Okay? So we'll ask the basic question. We're going to say, if follower is greater than 0. So if we're not at bucket 0, this means we have at least one guy before us that we can compare ourselves to. Make sense? Then we want to ask the question, is the guy before us greater than us? Should I switch places with the guy before position follower? So we'll write that in another if statement for right now. So we'll say if elephant at position follower minus 1 okay, whatever value that is, if that guy is greater than elephant at position follower. Now, if you don't like writing it that way, you can say if elephant at position follower is less than elephant at position follower minus 1. If you prefer to look at it from that perspective, that's fine as well. Is the current guy smaller than the guy before him? Make sense? They mean the same thing. If that's true, we want to do our swap thing. And what did our swap thing say? So we asked, are we at the beginning of the list? No. Is a 1 less than a 3? It is. So what did we do? We stored the 3 in temp. Then we overwrote position 3, well, position 0 in this case, with whatever was at position 1. Then we overwrote position 1 with what was in temp. So we need to do our swap logic. So we'll say temp is equal to elephant, name of our list, at position follower minus 1. So we'll preserve the previous guy. We'll remember that value. Then we'll overwrite that value with the current value. Then we'll overwrite the current value with whatever we had preserved in temp. Make sense? And finally, because we just did a swap, the follower follows. So follower is equal to follower minus 1. After we do this swap here, we swap the 1 and the 3. The follower will follow. Now, we want to keep doing this logic over and over and over again until follower either reaches the beginning of the list or we're not supposed to swap. Right? So we only swap when follower is 1 or greater and when we're supposed to swap. So when we want to do something over and over and over again, as long as some condition is true, what kind of red flag should be going off? What kind of tools should we be using? Some kind of loop, right? Some kind of loop. Because we want to repeat stuff. Loops are how we repeat stuff. All right? So we're going to go ahead and we'll leave that if statement stuff in there for a second because we're going to be pulling some of those pieces into our while loop. So we're going to say, when do I want to swap? I want to swap while follower is greater than 0. Or you could say it's greater than or equal to 1 if you prefer that. And elephant at position follower is less than elephant at position follower minus 1. While both of those things are true. Now, you didn't have to put it as an and statement like that. You could have said, while this is true, if do this, and got out of the loop. But This is the cleanest way of doing it. So while both of these conditions are true, while we are greater than 0, so as long as we know we have a guy before us, and the guy we're currently looking at is less than the guy before us, both of those have to be true, then what are we going to do? We'll do our swap stuff. All right, so this is our swap stuff. Follower then follows. We spin back up. We ask that same question again. Is follower still greater than 0? Because remember, we just subtracted 1 from him. And should the should follower come before the guy before him? Make sense? Okay. This is it. That's insertion sort. So we come down here. We filled up our list with random numbers. We printed it out. Then we called insertion sort, passing it our list. And insertion sort is going to go through and sort our list.
You have to return.
No, I don't.
You don't wait.
No, it's
Why
working
not?
without return for me.
Well, we're going to, let's run it. We'll see it work. And then I'm going to ask both of you to explain why you're wrong and he's right. Because it's actually an important lesson. I mean, that's a really important lesson. Because but we'll also say that what he said, it's working for me without a return, indicates that he doesn't know why it's working without a return. Just that it is working without a
I
return.
couldn't figure this out.
All right. So let's take a look at this. How I close my terminal. That's the only way I have of remembering where this code is. Oh yeah, that's right. Somebody asked me last time who keeps it in downloads, right? This guy. Well, no, it's not in downloads. It's a desktop.
Yeah.
There we go. All right, so we'll say Python 3, CSC200.py. There's our original. There's our sorted. And we didn't use the built-in sort function. Make sense? All right, so a couple things to point out here. First of all, the way I just wrote this, did you see how I was drawing pictures and then adding things to my code at the same time? I would do a little bit of the algorithm work, then I would go and write the equivalent code. Do a little bit of the algorithm work, write the equivalent code. You're going to want to follow that pattern for a while until it becomes boring for you. Because eventually you'll be able to solve problems like this just in your head because you'll be able to remember 2 or 3 variables and a couple of loops and that kind of stuff. You'll be able to juggle those things. But for a while right now, you're going to need to draw these pictures and remember that, okay, I need cursor start. He's going to go from here to here. What kind of tool can I use to make that dude go from here to here? Just solve that problem. That was the very first thing we did, right? And then we said, okay, well, each time we start doing something, follower starts off being equal to whatever cursor start is. Just solve that problem. Then you start adding in the additional logic. Make sense? Trust me, you're going to want to follow those steps for a long time until you're legitimately annoyed with following those steps because you don't actually feel like you have to. And then the hope is, as a student, I'm going to be giving you harder and harder things where you'll never actually have to stop following those steps. Just the problems will get harder and harder, and you wouldn't have had to follow the steps for the easier assignments early on. All right, cool? All right, go ahead. Sorry.
Well, I cannot figure that out, but then I define them, and then I use it to sort my list. Is that okay?
So you used find min?
Yeah.
Okay, but then that's, okay, so tell me how you used find min to do it.
So if you use the min and the list, so you just find like the least number of that list, and then you attach it to like another list, and then you just like append it with like and then you delete that number from the list.
Okay. So what you did is you created a brand new blank list.
Yeah.
And then you looked at the original list and said, what's the smallest number in this? You added that smallest number to the new list, deleted it from the original, then you asked, what's the smallest number in the remaining list? So that is a sort, but that's not an insertion sort. So,
It works.
well, but so now we get back to the second part of your question. Is that okay? It's good that you figured out a solution to sort, but you didn't go through the process of learning how to do this algorithm. Because the ultimate goal here wasn't necessarily to have things sorted. The ultimate goal here is seeing a solution to a problem and being able to turn that solution into the equivalent code. Does that make sense? I mean, that's the skill. If you go back to the first week of class, we talked about one of the reasons that human beings have problems becoming good programmers is that we're so good at solving problems that we have trouble articulating how we solve problems. Okay, so in this case, what you did is you ran into a problem like, okay, I can't figure out how to solve it this way. So you found an alternative way to solve the problem, which is fine. I mean, you used the duct tape instead of the screwdriver and masking tape or something like that. So, you know, it's not like you'll lose all the points because it is interesting what you did. But one of the skills we really need to practice is being able to turn a solution to a problem into something like this. Now, what you did do, though, is you did come up with an alternative solution, and then you turned that into equivalent code. So you solved that version of the problem, just it was a different code problem that didn't require two loops. So you kind of lost the experience in working with two loops there, because you just whittled down one list. And you said as long as the length of that list is greater than 0, keep finding the minimum value and appending it to my new list, right? So she wrote this guy, def some kind of sort. This guy takes an elephant. And so you created, maybe called this guy sorted list. Start that equals the empty list. Then you said for I in range from 0 to length of elephant, we're going to do some stuff. And so what you did is you said min is equal to, and what's the min function for a list?
I think it's just min.
Yeah, I mean, I would guess it's this. Min elephant.
No, I did find that function. Like, I'm not using it as built-in. I did.
Oh, you wrote your own.
Yeah.
Okay. So you're earning some more points now. I like this. All right, so she said, hey, I don't know if this function exists. So she said, I'm going to write find min. And this guy's going to take in here. We'll call this guy we'll call this guy LST for list. And you're going to say min is equal to LST at bucket 0 for I in range. Actually, you don't even need to do the range thing here. We can do we can say for val in list. If val is less than min, set min equal to val. When all is said and done here, you're going to return min, which is the smallest value in that list. So we're going to say min is equal to find min, passing it elephant. So that's our minimum value. Then you're going to say, elephant dot remove, and we'll pass this guy that minimum value. So we'll dump it out of elephant. Okay, remember, remove removes the first element min from the list. All right, and then she went and said sorted list dot append min. Keep doing that over and over and over and over again until we've run out of stuff inside of elephant. That makes sense? Now, the problem, actually, this code right now isn't going to work quite right. Because right now, the length of elephant changes each time through our list. Does that make sense?
Yeah.
So it's actually shrinking down each time. So really, we need to do something like,
I use the while loop to do mine.
yeah.
Instead of something similar.
So we would say while length of elephant is greater than 0, as long as we still have stuff in that list. Find the smallest, remove that element from the list, tack it onto sorted list. Now in this case though, we would have to return sorted list because we did not change elephant. Instead, we built up elephant sorted here. So we would return sorted list. So then down here, instead of calling insertion sort, what did I call that function? Some kind of sort. Some kind of sort. We'll pass it my list. Length of elephant. Yeah, I didn't finish my function call. Oh, I'm still printing out elephant. I'm not printing out what was returned by this guy. So I need to print this guy. And that'll be our opportunity to talk about the return versus not returning thing too. So I'll print the result of calling some kind of sort because that guy's returning the sorted version, which looks like that. Okay, so we're getting it sorted now. Now, one thing we should be able to do here is we should be able to, instead of returning sorted list, we can go ahead, elephant at this point should be empty. We can go ahead and append all of the elements from sorted list onto elephant. What was that function called? Was it extend?
Yeah, extend.
Extend. So instead of returning it here, we would say elephant dot extend, and we would extend elephant with sorted list. So we would concatenate onto the end of elephant, which is an empty list, our now sorted list, which would then allow us to print my list out here. Because my list here is a synonym for elephant in here. So even though we were emptying out elephant here, when all was said and done, we threw a bunch of stuff back into elephant. We threw all of our sorted stuff back into elephant. So there's our sorted version of that without returning something. Does that make sense? All right, so now, so having said that, we're back to our question of, is this okay? It's somewhat okay. I mean, it's not like this is easy, what you wrote. In fact, really, this might be harder. So you would get most of the points, but you would still lose points for not implementing insertion sort. So something, if you got everything else right, something like a 90 or something like that. This isn't bad, it's just not insertion sort. Is the issue. And this is really inefficient. I mean, this is about as inefficient. This is maybe like kind of like, if all else was lost, you were trying to sort some stuff. Because effectively what you're doing here is you have a bucket filled with numbers, like little chips with numbers on them. So you have the entire bucket. And what you're doing is you're taking one element out at a time, trying to find the smallest one. Finally, you get the smallest one, you lay it to the side because you've removed that from the bucket. Then you start all over. You start with the same bucket that has everything in it that used to be in there with one less thing, and you search all of them again. Now, as humans, what would we probably do? We'd probably kind of dump it out and start kind of putting them in order. Like, oh, this one's smaller, and kind of drag it over here. Would it be a lot harder to write it that way?
Like how a human would do it.
Potentially would be impossible. because you have to ask yourself, what are you actually doing when you've dumped out all those chips and you're trying to put them in order? What's actually going through your head? Because you're kind of glancing at these things. There's all sorts of inputs that are happening as you're scanning over those chips that are dumped out over the table. You're looking at numbers and you're processing those numbers in terms of, is this kind of a relatively small number? Is this a relatively large number? If it's a relatively small number, we're going to kind of look and kind of fit somewhere over on this half of my pile. If it's a relatively large number, it's going to fit somewhere on this half of my pile. That kind of stuff. So you're doing a lot of kind of human-esque decision making. And that might be very difficult to capture in like true problem solving. Does that make sense? Because really you are glancing over all those things over and over and over again. You just maybe weren't kind of ruffling through the bucket, taking everything out one at a time until you found the smallest and then plopping everything back in there, because you would start spreading them out on the table so you could see them all at once. Does that make sense? Yeah. So couple of different approaches here. All right, so now the death match then. Let's just go look at Insertion Sort here. Why do I not need a return statement here? Why was this guy not needed? Would it break anything? Let's start with this. So if I called Insertion Sort on that, I'll comment out this one, and I'm returning elephant.
I would outside the 4.
You think it breaks it? Okay. Definitely doesn't understand the concept. Okay. I'm just teasing.
If you're going to use a return, wouldn't it be outside the 4?
I do have it outside the 4, don't I?
No, yeah.
Oh, I have it inside the 4. Okay, you get to answer again now. Is this gonna work?
No.
We're gonna want to answer the other way. Okay.
No.
So we'll run this sorted, right? Okay. But take that out. Still sorted. Question is why? Go ahead.
Is it because the insertion sort definition is you're keeping the same list, but you're just changing things about the list? So once you run insertion sort the function, the list will be changed. Then it'll be saved as that change, and then you can just print my list and it'll pop up properly.
Okay, that's a true statement. Let's pause that for a second.
Okay.
Here's my function insertion sort, right? Here's me calling my function insertion sort.
Mm-hmm.
So this is me defining it.
Yep.
This is me calling it. Now we happen to look at this code and we see that this guy returns elephant, right? So it returns a value. What am I doing with that value? Nothing. I'm watching it fly by. I'm calling insertion sort. It fires out a list at me, and I just kind of move. I'm not storing it in a variable. I'm not printing it. I'm not doing anything. If I were to say, well, I'm going to go ahead and print it, I'll print that value. Now we'll get it sorted twice. We'll see the output 2 times. This is the result of calling insertion sort.
Mm-hmm.
This is the final version of my list, which is called elephant inside of insertion sort, which was, as you pointed out, changed permanently. That guy is a pointer. Go ahead.
I was going to say because it's all contained within the list, right?
It's all contained. I'm not sure what that means.
Like the changes are all contained within.
The original list. Let me show you a picture that I think will explain this. So we have our variable called my list. And my list, just so I don't have to draw anything, is our list in memory somewhere, right? This is a list that has 100 elements in it. So we're going to say that my list points to this guy. All right. Then we have our function here called insertion sort. And inside insertion sort, we have a variable called elephant. Correct? Actually, I'm going to write it underneath this. Let's do both of these. Elephant points to the same place in memory as my list points to. So inside insertion sort, we're making all these changes to elephant, right? We're swapping stuff. That's swapping up here in memory. Once this function is over, once it dies, my list still points to that changed list. That's why I'm able to print out my list back in the original program without having it returned to me by the function. Because I have a variable that points to the same place in memory as elephant did a couple of moments ago. Make sense? All right, so at the end of the day, what does this say for us? This says that lists are passed by reference. So changes we make to them are permanent changes. Got it? All right, Bible homework will be up this morning. No homework for Wednesday, but you will have homework for Friday. Once again, I'll put these times up. If you are interested in this Bible VR thing, first timer meetings tonight, 4:30 in the room right next door. Be there. If you can't make it to these meetings, don't worry about it. There'll be other opportunities. But these, you need to be there at all of them. Sure.